Okay, so I mentioned before we're gonna need these plexiglass to separate these cells so that they don't short each other out. These I just got from Home Depot. They're made in USA. And the length that you want them to be is roughly this dimension, and that's pretty much this ruler's width. And to put in perspective how thick they should be, how long the width should be, is roughly this much. And the reason is you don't want to make it too overly wide, so that then your wires is coming all the way around. It's difficult to work with. You don't want it too close because you don't want it too short, because then it doesn't serve its purpose of separating the cells, the tabs. So this distance is roughly the best you're gonna get. Okay, so that's what you need to do. And I don't know exact dimension on this, but I mean if you guys measure, well, I actually have a ruler here, which doesn't make sense to not show you guys what it is, but here's a metric. It's roughly 5 centimeters. I'm not sure you can see it right here. It's probably not as good, but anyways, it's 5 centimeters in width, and then of course this plexiglass itself is whatever you can get from Home Depot, and it's perfect actually. It fits the same length of it. So anyways, you need to cut a bunch of these, and the tools that I use to cut that is one of these. Now you can get a different version from Home Depot. They're essentially the same thing. I want to show you how to do one of them. So I don't know exactly sure what this tool is called, but when you buy the plexiglass, it should be right next to it. So I'm going to use one as a gauge or a reference. So the way you use this, again, this is in the instruction when you actually buy this. They'll tell you that you need to do this. Basically, you're going to score it multiple times. And of course, you got to do it on the other side so that you can easily break it apart. Now I'm doing this fast because I've done this tons of times before, as you can see, and so you might take a little longer, and once you got it there, you can just bend it and it breaks off, and there you have it. As you can see, for the most part it's off. That yellow, I guess, glue, the edges are still protected. So all I did was just kind of strip them down a little bit so that the plexiglass can slip in there a lot easier without any obstruction. So I would highly recommend doing that as opposed to stripping everything out and leaving the edges exposed. And again, just the reason why you want to keep them in there is a couple reasons. One is to make sure that you protect the edges so it doesn't scratch you or scratch anything else. But second of all, these edges might peel off over time and open up the whole cell itself and expose it. So it's just a good safety caution. I mean, these right here are protected. They're stamped down pretty solid, but these aren't. So the edges aren't. So that's the reason why you want to do that and not take them all out. This is the separation that you want. And let me angle it up a little bit. As you can see, you want to separate the bottom cell with the middle cell, and you want to do that completely, because once you start normally, as you can see, the way it connects before is these two are parallel together, and so if these two guys touch each other, that's fine. But what you want to do now is convert that into a series. So what's going to happen is this side is going to connect to here. If this side, which is in this case the positive, connects to here, which is a negative, that's totally fine. But if you don't separate them with the plexiglass, what's going to happen is if you accidentally short here, then what's going to happen is positive goes to negative on the same cell, and so they'll short that cell out. So what you want to do is put this protection in between, as you can see. So remember, this is negative, this is positive. So positive to negative. Now the other two cells at the top are actually opposite. As you can see, now it becomes the positive actually on the top. Actually on the right. So the bottom one, the positive is on the left, top one's on the bottom, the two top on the positives on the right. So again, similar story on the top, but in the middle it gets a little iffy because what you want to do is, let me remove these two sides so you can see a little better, is these two, which is a positive, and in this case it will be negative, should be soldered together. And so once it's soldered together, that means that this side cannot be touching each other, and so that's why there's only half of what you only need to protect half of it. And so you will put the plexiglass like so. And keep in mind, you want to make sure that you cover enough of this. So this is the cell division. As you can see here, there's the cell division that I'm moving back and forth here. You want to be able to completely cover this. It's okay to not go out here. It's okay to have something that maybe extends possibly all the way out here. But you need to cover at least all the cell here, because even the one accidental short between this will short your cells out. So what you want to do is put it in between like so. So there you have it. I'll definitely have a picture of this, and let's remove all this, and then that way you can see all the tabs properly, I hope. So the way it's going to go is a wire goes from here to here. These two are soldered together. Wire goes from here to here, and then you're done with this set. And you do that for the other three. And then finally, the end tab will be here and here. Alright, so what I'm doing now is I'm creating these connector wires. I have these, I'm not sure you can read it, but they are 14 gauge. I think it's called Teflon. Yeah, 14 gauge Teflon wires. So they're good for 200C. Now, I'm actually doubling them up because if I'm going to run high power through my controller, it's going to draw on average 40 amps or 30 amps to 40 amps, which is fine for one actually. You know, just if you look up what rating for a 14 gauge wire is rated for, it's going to be like maybe 20 amps or 15 amps for a short distance. But that's kind of like about a foot or two. These wires are a lot shorter, and moreover they're actually silver coated with Teflon in it, so it can withstand quite a lot of heat. And so one of them would actually do fine, and that's what I have on the other one. But for this second build, I'm just over engineering it and having two as opposed to one. And again, I just coil it up so that it stays together pretty nicely. Some of these RF engineers might say, oh, doing that is actually better because it reduces the noise and whatnot, but it doesn't really matter to me. Now, what else I'm building is actually these guys, and essentially what they are is they're the same wire, and as you can see, the silver, so they're not like copper. They're copper core but silver coated, stranded. So what I'm doing is I'm stripping them and I'm doubling them up again. Also, same story here. So you put them together, wrap them up, and then you're good to go. And what they are for is actually going to be for, I'm not sure you can see, connection here to here. It's one of those short connections that are real close. So turns out, if you do the math, it comes out that you need 2 per cell, 2 of these long ones, and one of the short ones just to build the isolated one. But when you put those 2 together, you're going to need another small one, which goes from here to here, I believe, once you stack them up. So that means that in order to have 3 cells, you will need 6. So 6 of these long ones, and 3 of one of these, 3 of these, so that you have 3 cells stacked. But also you need additional 2 of them because this stack will connect to the other stack, and then the other stack connects to the top one. So total of 5 of these short ones. Once you build those, then you're good to go. The last thing you would need to do is, I have done this already, is you need these balance cable. Now this is just a black one I got. You could be colorful and have some color coded one. But anyways, the point is, you have these black one, and ideally what you want to do is wrap them up here. The next thing after this is you will have to solder all these together so that they stay together. You want to do this because then once you have it each balance wire on this, then it becomes easier. You don't actually have to solder them afterwards. And I found out the hard way because I solder these wires first, the white ones, and then I try to put the balance wires on, which then heats up the solder, and then it might disconnect again. So just to do it ahead of time, have the balance wires already on there, and if you want, again, you can wrap them all up or something like that, and then have it come out later on the other side. So anyways, that's that. So you would have something like this at the end of the day before you actually solder on there. So solder all those together so they stay together. Similarly for these, solder them together, and then of course you also have a balance wires on that as well. You would do something like this, and then you run this one out. So once you have all that set up, your operation will go a lot faster. Again, I'm using Teflon wires. You guys are welcome to use any other one. The only reason I'm using Teflon is that they're thinner. The insulation is thinner. If you use the silicone one, they're totally fine also. The only problem is they're a little thicker, the insulation, so then it makes it a little more difficult to handle. Of course, they're trade-off. These are less flexible, but then I figured that's what I want anyways. I don't want it to be flexing all over the place. So what I'm doing now is I use this tool. Not sure what is it called. Wire cutter, I guess. Yeah, you can get this on Amazon for like $35 or $36. I forget how much I got this one for. But they're used to just separate, to strip the wires essentially. So you want to do something like that, make it a little longer, make it really long. So that helps speed up process instead of using one of these wire cutters and then just cut it. But anyways, so this is a wire cutter. This is I guess a wire stripper is what they call it. Anyways, you get something like this, and at the end, what you want to do is you just think ahead of time. You want to just isolate the edge and isolate the cells. So I just got a bunch of electrical tape that I cut from here using scissors, of course. So what I would do is I would keep black and a red one separate, because those are and you're gonna need 13 of these wires. So I have 13 of them created, and the reason why you need 13, it's not a good number, but there's gonna be 12 cells here. So in order to make a balance wires for them, you need 13 of them. So you need to create 13 of them, and I would keep the black and red one separate, because those are the kind of the ground and the power of the balance wire. The rest, go ahead and use them. I didn't have enough color, so I just reused some of the red ones in there, but it doesn't really matter. So what you want to do then is wrap those around here as best as possible, and then that's pretty much it. I mean, you can get fancy and just wrap it around like that, and so then there's your balance wire. So when you connect them like so, you have this so that you can connect it to the outside. So go ahead and do this for pretty much all of the balance wires that you have. And again, the balance wire is important because these are lithium cells and you do want to keep them balanced. So anyways, you get the point. I will do one for the small one, and it's no different. You just wrap it around like so, and there you go. There you have it. So go ahead and do it for all the other ones, and then you're good to go. Once you've done all that preparation, you're ready to solder. And the soldering process shouldn't take too long if you have the right tools. And this is what you want to use. This is an 80 watt welder, soldering iron, made by Weller. And I got this about $35, $36, so it's not that expensive, and I would highly recommend getting one of these. I used to use one of those smaller ones, the ones for a PCB board, and they definitely do not have the power to do what you need to do. I just a green environmentalist guy, I guess a hippie sort of, not really, but I use lead-free solder, and so that's the reason why you can probably get away with a thin tip if you use a lead solder base, because then it works better. But since I'm working with lead-free solder, I need to pump the temperature a lot higher, and and that's why I'm using this giant soldering iron. The last tool you would need is double-sided tape. So I have a ton of these here. You don't need all this to start with, but you just need some of it. So, and of course your regular tools that you would need. Again, the tape was kind of messy, but you get the point. I mean, you know, you would need these wire cutters, I guess pliers here, wire stripper. You got your scissor for your electrical tape. You got your Teflon wires or regular wire. Always solder. When you solder, use a safety glass. You don't want hot solder on your eyes. You got your wires, the colorful ones, and of course your battery. Then you got your plexiglass. The previous tool that I told you guys about is this plexiglass cutter that you would use to cut your plexiglass. A ruler to kind of score it properly. And you know, you can use anything that's straight. In fact, you don't need the ruler at all. And of course, you know, you solder itself, and that's pretty much it. I mean, in terms of tools to get this up and running. Alright, so what I have here is the apparatus. I'm just using these clamps to hold these wires. We made the preparation that I did, and this is the point where I'm going to solder them. Again, I have this giant 80-watt welder, and I have this trusty, I guess, solder sponge, metal sponge. And so just to clean up the solder tip,